All right, today we're going to dive into one of your body's most amazing and honestly essential jobs, making urine. Okay, get this. Every single minute of every single day, your kidneys filter all of your blood, the whole lot. It's this massive, nonstop cleaning operation happening inside you right now. But how? How does your body actually pull that off? Let's take a look. So, here's how we're going to break it all down. First, we'll peek inside the kidney's tiny little filters. Then, we'll walk through the 4 main steps of making urine. After that, we'll follow its journey out of the body. And finally, we'll talk about why all of this matters so much. All right, our story starts deep inside the kidney in what's basically a microscopic factory. I mean, it's so tiny you'd never see it without a powerful microscope. And this is where all the magic happens. And here's the star of the show, the nephron. It's our hero today. You have about 1 million of these little powerhouses in each kidney. 1 million. The nephron is the real workhorse, the main factory floor where blood gets cleaned and urine actually gets made. Okay, so let's get into the main event, shall we? The whole process is kind of like a super efficient assembly line. It's got 4 main steps, and its whole job is to clean your blood perfectly and keep your body in balance. So what are these 4 stages? Well, you've got filtration, that's the big squeeze. Then reabsorption, where we grab all the good stuff back. After that is secretion, which is like a final cleanup. And last, concentration, where we make sure the water balance is just perfect. Okay, first up is filtration. Your blood flows into this tiny little ball of capillaries. It's called the glomerulus, and it's under pretty high pressure. Now, imagine you're making pasta. The glomerulus acts like a really, really fine strainer. The pressure forces all the small stuff, like water, salts, and waste, like urea, right through the holes. But the big stuff, like your blood cells and important proteins, they're too big. They stay behind in the pot, which is your bloodstream. So, all that liquid that just got squeezed out, that's what we call primary urine. It gets collected in this little cup-shaped thing called the Bowman's capsule. But, and this is a big but, this is not the finished product. Not even close. You can think of it like a rough first draft because it's actually filled with a bunch of really useful stuff that your body definitely does not want to get rid of. And that brings us right to step 2, tubular reabsorption. I love this step because it's all about being smart and efficient. Your body is no fool. It's not going to just toss out valuable stuff. So this is the reclamation phase. It's where the body says, hey, wait a minute, I need that back. So what exactly is it taking back? Oh, just all the good stuff. We're talking glucose for energy, you can't just throw that away, amino acids for building things, plus just the right amount of salts and, of course, water. All these essentials are pulled right out of that first draft urine and put straight back into your blood where they're needed. All right, so we've filtered the blood and we reclaim the good stuff. What's next? Step 3 is tubular secretion. Think of this as the final quality control check. Your body takes one last look at the blood and says, did we miss anything? And it actively yanks out any leftover waste that might have slipped through the first filter, things like extra ions or maybe some toxins. And that brings us to the final step, making concentrated urine. This is where your body makes a really important decision, and it all depends on how hydrated you are. It's basically asking itself, do we need to save water right now, or can we afford to let some go? It's a delicate balancing act, and it's all controlled by one very important hormone. And that hormone is called vasopressin. It's pretty simple, really. When vasopressin is around, when it's on, it tells the kidneys, hey, hold on to water. So more water gets reabsorbed and your urine becomes more concentrated. But if vasopressin is absent or off, the kidneys don't get that message. Less water gets reabsorbed and you end up with very dilute urine. In fact, a lack of this hormone causes a condition called diabetes insipidus, which makes people urinate a lot. And there you have it. The assembly line has done its job. The final product, urine, is officially made. So now what? Well, let's follow it on its journey out of the body. The path from here on out is pretty straightforward, kind of like a one-way street. It goes from the kidney, down a tube called the ureter, then it hangs out for a bit in the urinary bladder, and finally, it makes its grand exit through the urethra. Now, these ureters, they aren't just lazy pipes. No way. They're muscular tubes about 30 centimeters long, and they actively push the urine down to the bladder. They do this with a cool wave-like motion called peristalsis. And hey, that might sound familiar. It's the exact same kind of movement your intestines use to move food along. Okay, next stop on our tour is the urinary bladder. It's this stretchy, pear-shaped bag that's basically a temporary holding tank. And it's pretty impressive. It can hold somewhere between 300 to 800 milliliters of urine. That's like a medium to large-size drink bottle. And the final leg of the journey is through the urethra. This is simply the tube that takes the urine to the outside world. There's one interesting difference here, though. In females, the urethra is pretty short, only about 4 centimeters. But in males, it's much longer, more like 20 centimeters. Okay, so we've zoomed way in on the tiny details, and we've followed the whole exit route. Now, let's zoom back out and look at the big picture. Why does all this matter? Why is this incredibly complex process so important? Let's tie it all together. So here's a little thinking question for you. Ever notice how you have to pee more often in the winter? What's up with that? Well, it's actually pretty simple. You're not sweating as much. When it's cold out, your body doesn't lose a lot of water through sweat. So your kidneys have to pick up the slack and get rid of that extra fluid as urine. And here's another one to ponder. What if that super important reabsorption step just didn't happen? Especially for water? Well, without it, you'd be losing massive amounts of water all day long. You'd become severely dehydrated, like dangerously fast. It really shows you just how critical that step of taking water back really is. So if there's one thing to take away, it's this. Your kidneys are so much more than just a waste disposal system. They're like master chemists constantly working inside you. They filter, they reclaim, and they keep everything perfectly balanced. It's an absolutely incredible system, working silently, 24/7, just to keep you healthy.